All right, folks, welcome back to our lesson on circles and arcs. We talked about arc length, we talked about naming arcs, and now we're going to dig into finding out arc lengths. So let's take a quick review. If you haven't watched the previous two videos, please do that. We talked about what makes up a circle with our center and our radius, our diameter, our central angle, our circumference, bits of the circumference called the arc. We talked about arc measure, which is related to central angle, and we talked about the addition postulate working for that as well. So now we have another note about the circumference of a circle. So we're getting back to circumference, which is all the way around. Now we can find the circumference one of two ways. We can either use just the radius and call circumference 2 times pi times the radius, or we can use the entire diameter and call that pi times the diameter. So what does this mean about diameter and radius? Hopefully you know this. The diameter is 2 times the radius. Isn't that a neat little tidbit to know? So these formulas are actually the same. It's the way around the circle, because pi is the ratio of a circle's circumference to its diameter. So it all works out very well. And it's the same ratio for every single circle. It's a magical number. And so we need to remember that about circumference. And that's going to talk about arc length. Okay, so we're going to talk about arc length. The actual length of an arc, when we actually measure it. Not with the central angle, mind you, but the actual measurement of the piece of circumference. It's the product of the ratio of the measure of the arc to the whole circle and the circumference of the circle. So it's this crazy formula that you can feel free to remember to know. The question is, though, how are we going to find this actual distance from A to B? How could we measure that distance if it's curvy like that? And here's my, this is the book way, here's my way. My way is it's all related to 360 degrees. It's all related to the full circle. So all the way around is the entire circumference. If we're just trying to find a bit or a piece of that circumference, we can use proportions. So check this out. If we're looking at the measure of angle AOB, which is right in here, and we compare that to the entire circle, okay, the measure of angle AOB compared to the entire circle, that would be equivalent to the comparison of the arc AB to the entire circumference. So if it's all proportionality. Okay, so the measure of that central angle compared to the whole way around is completely proportional to the measure of the arc to its whole way around. Now, why is that true? Again, because the previous lesson, the measure of the arc is equal to its central angle, okay? So as far as the degree measure goes, but we can actually measure the distance. So let's see how that would work, okay? We're going to do a couple questions here. Let's start with a word problem. And this one's hard to see. So we have to know that the whole way from the center to the outside is 16.1 feet, and then the distance in between, 4.7 feet. So here we have a problem. A car has a circular turning radius of 16.1 feet. That means the outside tire, if going around a fixed point, the radius will be 16.1 feet. The distance between the two front tires is 4.7 feet. So the distance between the two tires is 4.7 feet. How much further does the outside tire go than the inside tire? So this is a question about comparing circumference, and we have to know that. So we are going to compare circumference. And so we're going to have to talk about the circumference of the outside. Okay, so we're going to talk about the outside versus the inside. Okay, so we have to talk about the outside tire versus the inside tire. We're going to compare circumference. So hopefully you can read this problem and understand that. If not, that's going to be the challenge. So make sure as you read a problem like this, you understand we need to start comparing circumferences. So the outside circumference is dependent upon a radius of 16.1 feet. That's the radius of the outside tire. Now the radius of the inside tire is not 4.7, it's 16.1 minus 4.7. So the radius of the inside tire around that fixed circle is going to be 11.4. Okay, so we have to see the difference. So the radius, if all the way from the center to the outside is 16.1, then from the center to the inside tire is going to be 11.4. And so that's what we're going to do. We're going to be comparing the distances that the tires travel. Okay, so how far has it traveled? That's a circumference question, and now we have everything set up. So we're going to compare the circumferences. So of course, if we're given a radius, we know our circumference formula. Circumference equals 2 times pi times the radius. So when it comes to the outside tire, the circumference is going to equal 2 times pi times 16.1. And when it comes to the inside tire, the circumference is going to be 2 times pi times 11.4. So all we need to do is find out these circumferences and then subtract, and then we'll be able to determine the difference in the distance that the tires travel. So hopefully that makes sense what we're about to do. So from here we can either use algebra or calculator work. Let me use calculator work first, and then I'll leave space and I'll show you a neat algebra trick. So we're going to use calculator to determine the circumference. So 2 times pi times 16.1, it gives us a circumference of 101.2, and then we have 2 times pi times 11.4, and that gives us a circumference of about 71.6. Oops, 71.6. And so all we have to do now to compare these two is subtract. And so when we subtract these two values, we end up with our answer, which is about 29.6, give or take. But we'll call that 29.6 anyway. So the difference is when we subtract. Okay, so we're going to subtract to find the difference. And so 101.2 minus 71.6, that gives us our difference of 29.6. Okay, so that would be the answer. 29.6, in this case, feet. That is actually the answer. That's how much further the outside tire goes. But let me show you algebra. So notice what's happening. We're going to subtract these two values, and we know that. So 2 pi times 16.1 minus 2 pi times 11.4. Right? We can do that. Now, they both have a 2 pi in common, so we can factor out a 2 pi. And then we end up with 2 pi times 16.1 minus 11.4, or simply 2 pi times the difference that was given in the problem, 4.7. And then we have, again, 2 times pi times 4.7, boom, 29.6. Or in this case, 29.5. So in this other case, we get 29.5, which is a more accurate measure. But that's how we can work with this. Okay, so we have to understand that we're talking about distance. Circumference is an actual distance, and how we can find it. All right, so we will continue with working on circumference with arc length. But now instead of the entire circumference like we did in the last question, we're going to work with a piece of the circumference. Here's a couple of examples where we have to deal with only a part of the entire circumference, just a piece of an arc. In both of these cases, minor arcs. So we'll look at the first example here, and it's asking what is the length of the arc shown in red, and leave your answer in terms of pi. Okay, so this is going to make things a little bit tricky, but I'll show you a few tricks up my sleeve as well. So we're looking at the red arc length from x to y, and we know what the measure is in degrees. Okay, so we know it's going to be a 90-degree arc. Hopefully you know that. But what we need to know is the actual length. Like if we're going to measure that thing, what would it be? And that's where this 16 inches comes in. So you remember, like we said in the notes, everything is in regards to the full circle. Okay, so it's all related to the full circle, and we can think proportionally. Okay, so if we know that the central angle is out of the full circle 360, then the arc we're looking for is out of the entire circumference. So we can think proportionality. Okay, the problem is we don't know the entire circumference. Well, we don't know it yet. If we remember how to find circumference, we can say it's either 2 times pi times the radius, or in a more suitable way to look at it, pi times the diameter. So in this case, the diameter being 16 inches. So we can already tell by this circle, even though we feel like this problem is way, way challenging, we have to remember we're looking at the circle as a whole. And so we already know the circumference is going to be 16 pi. All right. So we have found now our entire circumference, and what we're doing is looking for the tiny bit. So just like we said in the notes, we're going to think proportions. Okay, we're going to think proportions. It's all out of 360 degrees. So this 90 degrees is out of 360 degrees, just like the arc we're looking for, okay, in this case, arc xy, is out of the entire circumference. And the entire circumference is 16 pi. So right there is the hard part. Hard part is done. If you can understand how we get to this, then you're fine. Okay, but it's all related back to the note that I talked about previously. Okay, so it's all about relating to the entire circle. And now I'll show you a couple tricks. So check this out. We're going to multiply, cross multiply, and divide. And so we know what would happen. I'm only going to show you this once. When I use my cross products, I have xy times 360 is equal to 90 times 16 pi. I am not going to multiply that out because, again, I'm going to show you a couple tricks. All I do know is that to solve for the arc xy, we're going to divide both sides by 360. And that's an important thing. So check this out. We're going to do some fun math. I'm going to write down what we're working with a little bit bigger so you can see what is about to happen. We're going to talk about what goes into other things, numerator and denominator. Start marking some stuff out. So take, for example, we have a 0 here and a 0 here. So 0 in the numerator, 0 in the denominator cancels out. So the zeros are gone. So now we're looking at is 9 times 16 over 36. Okay, that's 10 over 10 is 1. So now 9 can go into 36. Did you know that? Hopefully you did. Hopefully you know 9 goes into 36 4 times. So now what we're looking at is a 16 in the numerator, a 4 in the denominator, but wait, there's more. Because 4 goes into 16, so 4 can go into 16 4 times. And now everything in the denominator has completely canceled out, and what we're left with in the numerator is 4 pi. So when we have divided all of that stuff out, we're left with 4 pi. So what does that mean? That means in terms of the arc measure of xy, okay, the measure of arc xy is going to be equal to 4 pi inches. And that's how that works. So again, if you can think proportionality, work with that. Or listen, if you're a formula follower, and that's all you want to do is follow formulas, then this one's for you, right? But I'm not a formula follower. I like to see things and how they relate to other things. So I'm not a formula follower. I know that everything is in relation to the entire circle. And so that's how that will work. Well, let's see if we can do the same thing on the next example. So again, we're going to look for the arc length in red, which is not what the actual textbook had, but I'm going to do this one a little bit differently. So we're still looking for the arc length in red. So that means we need the degree measure of the arc. So that's interesting. We don't even have that. Okay, we don't have the degree measure of the arc. What do we have? We have the degree measure of the major arc that is not 240. So how is it that we're going to find this central angle? You better put your thinking caps on. Too late. We're going to subtract the 240 from 360, and then that will leave us with our central angle that we're working with, which leaves us at 120 degrees. So we know that the central angle we're working with the arc length that's in red, is 120 degrees, which means the arc measurement degree-wise is 120 degrees. But that is not the question. The question is find the length, the actual measurement. The challenge is all we know is the radius of 15 centimeters. And again, what we're going to do is think how it relates to the circle as a whole. So we're going to do that. Circle as a whole. Pun intended. So the first thing we need to do is find the entire circumference. We can do that from the radius of 15. Circumference is equal to 2 pi r, or 2 pi times 15, or circumference is equal to 30 pi. So we have our entire circumference. We have the degree measure of the arc length in question, and as you recall, we're going to compare it to the circle as a whole. Our central angle is 120 degrees, but that's out of 360 total. That will be the same as the arc measure we're looking for. Again, still xy, so arc xy, but that's out of the entire circumference. Okay, and the entire circumference, as we just saw, is 30 pi. And again, that is the hard part. The hard part is now over, done. Everything else is algebra. And again, I'll show you some shortcuts. So we're going to use cross products, and we're going to divide. So arc xy would be equal to 30 pi times 120 divided by 360. In case you remember, I told you I was going to show you where it was the same as what we've done before. And now we're going to use our neat little tricks. Check this out. Look at our 120 and our 360. The zeros cancel. But even better, there's a 12 in the numerator, a 36 in the denominator. Did you know 12 goes into 36 3 times? And double check this out. That means we have a 30 pi left in the numerator, but a 3 in the denominator. 3 goes into 30 10 times. We are left, indeed, with 10 pi. So the measure of arc xy is equal to 10 pi centimeters. And now we have the actual length. Okay, so the degree measure of that arc was 120 degrees, but the actual measurement's 10 pi centimeters, so about 30 centimeters. But that's how that works. Okay, so we can use those skills with finding arc length. Now, to wrap up this video, let's take a super quick quiz. Yeah, let's do it. Okay. So in the first question, it's asking, what is the measure of arc WX, which is here, in circle V? Oh, well, you know what? For me, that's kind of simple because I can see this is 87 and the whole thing is 180. So 180 minus 87. Borrow the thing, take care of the 1. 93 is our answer. Boom. That was nice and easy. How about the second question? In case this one's a little bit better. I like it. Which is greater, the circumference of a circle with radius 3 feet or the distance around a semicircle with diameter 16 feet? And by how much? Well, we got two things at play. Let's compare each. Let's talk about the circumference one first. And that's of a circle. So in the case of a circle, the radius is 3 feet. So the circumference is 6 pi. Remember, 2 times pi times the radius. What's going on with the semicircle? Now the semicircle would be the circumference divided by 2, right? The circumference is the entire circle. Semicircle, we're going to divide by 2. So if the diameter is 16 feet, that means the circumference is 16 pi, but we're going to divide that by 2, so our semicircle is 8 pi. So our circle is 6 pi, semicircle is 8 pi. Which one's bigger? Dude, semicircle, but by how much? Well, 8 minus 6 is 2. Semicircle by 2 pi feet. Okay, so that's how we can do some quick thinking on those. And that's it for this whole lesson. I hope you guys enjoyed the videos. Check back in for the next one. See ya.